Hi students, today we will discuss about 11th standard 12th unit. Chapter name is Organic Chemistry, some basic principles and techniques. So here first we need to discuss this introduction part, introduction, tetravalency of carbon and structural representation of organic compounds and 3D representation of organic molecule. So we will discuss this one. First introduction. We are discussing introduction of organic chemistry. Everything in universe made up of organic molecule, organic compounds. So made up of carbon only, everything that is medicines, fertilizers, pesticides, clothes, cosmetics, medicines, chemicals, everything made up of organic compounds only. So here Bergelius, one scientist, he said that organic compound we can't prepare in laboratory. Like he said, he introduced one theory, that is vital force theory. Vital force theory. According to this theory, organic compounds obtained from plants and animals organic compounds obtained from plants and animals. Inorganic compounds obtained from minerals. Obtained from minerals. Inorganic compounds obtained from minerals, organic compounds obtained from plants and animals only. In laboratory we can't prepare by using any minerals, we can't prepare organic compounds, he said. Who's Bergelius? After 1828, at that time older scientist came. He proved that with inorganic molecule, that is ammonium cyanate, ammonium cyanate formula NH4CNO, ammonia cyanate. On heating ammonia cyanate in laboratory, he introduced ammonia, urea, C double bond O NH2. This compound, this is urea. From where ammonia cyanate on heating in laboratory, he was introduced by with the help of ammonia cyanate, urea he is introduced. So this is the first organic compound comes from inorganic compound. Organic compound prepared from inorganic compound. This theory now failed, because this theory what inorganic compounds obtained from minerals, but organic compounds obtained from only plants and animals. But this is organic compound, it is comes from inorganic only. No, this is inorganic compound. From inorganic compounds in laboratory we will prepare urea also. He is proved that older scientist. Okay, this is the introduction of this concept. Okay, next tetravalency. What is the tetravalency of carbon? What is tetravalency? Tetravalency means, second one, tetra means 4. Tetravalency. Tetra means 4, valency means combining capacity. So carbon combining capacity is carbon combining capacity is 4. Carbon combining capacity is 4. So that only we will call tetravalency, carbon having. Carbon electronic configuration is equal to atomic number 6, 1s2, 2s2, 2p, 2. So valency electrons means last shell. how many electrons is there last shell, what is the last shell, second shell is last shell, here electrons 4 is there. So that is the valency of carbon, that is the valency of carbon. This is about tetravalency of carbon. Next here some compounds, organic compounds example we are taking for this one. Example is CH4 and C2H4 and C2H2. So this is methane molecule, this is ethene, this is ethane molecule. So carbon having tetravalency, you know that. So now here hybridization of CH4 is CH4 hybridization, C2H4 hybridization and C2H2 hybridization. CH4 hybridization, sp3 hybridization, and this one hybridization sp2, and this one hybridization sp. Here number of bonds between atom is 1, here double bond, here triple bond is there, So triple bond is there in triple bonded carbon atom hybridization is sp, double bonded carbon hybridization sp2, and triple single bond hybridization is sp3. So here what is the S percentage here? S percentage, S means this s orbital hybridization in s orbital percentage is 25 percentage s character is there, 25 percentage s character and 25 percentage s, remaining 75 percentage is p character. Okay, next here in this compound double bond ethene, this one is sp2 hybridization, 33.33 percentage s character and remaining 66.66 like percentage is p character is there. Okay, s and p characters. Here sp 50% s character and 50% p character is there. So p orbital hybridization in s character 50, p character 50. Why I am telling this 50 and 50? No, s character increases, s character increases. What happened? S character increases, bond will bonds will be very strong bond, and short also, short and strong, or very strong bond, or short also, short bond. Length, short means length will be less, short or length will be less. Why length will be less? For carbon structure I will write here, CH4 like this is there, all are single bonds. Here C double bond C like this structure is there for this one C2H4. This one triple bond is there between one hydrogen. This is a linear shape. Here triple bond means length between these two atoms will be very less, because s character is more. After that what? Sp length is less than sp2, it is less than, that means it is moderate. Sp length is sp2 hybridization bond length and strength also moderate than sp and sp3 hybridization because of s character. Next, s character increases, one more, s character increases, electronegativity of carbon or molecule of that increases. So how it will come? S character, sp. In sp, otherwise we will take molecule. CH4 is less electronegative than C2H 4 H4, and then more for C2H2. So electronegativity order is this one. This is sp3 and this is sp2 and this is sp. So this is a hybridization and molecules of ethane, ethane and methane. Tetravalency means 4 carbons. This is about fully that tetravalency of carbon. Next we will take how it will, here 2 bonds is there, otherwise here 2 bonds is there. So in that, one is pi bond, other one is sigma bond. Which one is pi bond? Any one is pi bond, second one is sigma bond. Pi bond, how it will form? So special type of bond present in these molecules. So pi bond, how it will form? See, I will tell. Pi bond, for example, we will take C2H4 molecule. Here carbon atom, between carbon atom pi bond is there. How it will form? No, carbon atom having atomic number 6, 1s2, 2s2, 2p2. No, in these 4 electrons is there. Where it is? Here s orbital 2, here p orbital also 2 is there. But here how many bonds is there? Total 4 bonds. How it will be possible 4 bonds? That's why this electron will goes here. Then this is px, py, pz, like this is s orbital. Okay. Here what happened? No, these orbital, this empty orbital or this orbital will do what? So that orbitals, hybridization orbitals I will write. What is this hybridization? sp2 hybridization. That means 1 s orbital, 2 p orbital, these 3 intermixing. 1 s orbital, here no electron, 1 s orbital and 1 s orbital, 2 p orbitals only intermixing will form total how many? 3 orbitals, hybrid orbitals. 1 2 3, no, 3 hybrid orbitals, but one is not involved. That's why sp2, 1 s orbital and 2 p orbitals involved. It will form s, that and all chemical bonding chapter you will also listen. S orbital 1 spherical shape, p orbitals how many? S plus 1 more p and 1 more p, 2 p's. But one more p is there, px, py. This is px, this is py, pz is there. No, this is not involved in hybridization. That's why sp2, sp and p2, no, sp2. Now this will form what? How it will form? No, how it will form bonds? See, and orbitals, this is intermixing. After hybrid orbital 3 will come. That hybrid orbital, one is having this loop, big loop, second loop is very small. This one having big loop, second one have small loop. This one having big loop, this one is small loop. See, that means like this 2 and this one will intermix. Like this 3 orbitals will form, that is a big loop and small loop. One big loop and a small loop. One more big loop and small loop. Total how many? 3 orbitals formed. This 3 I will keep here. How I will keep? 1c. This is this is carbon atom. For 1 carbon about we are discussing now. So this is big loop having 1 electron. Okay na? Here 1, here 1, here 1 is there. No, 3 electrons we will represent. Okay, next small loop this side is there. No need to write. Here 1 bigger, here 1 small loop is there. Next this side also 1 loop is there. This one only I wrote here. 1 loop is there. Same this carbon also like that. No, 1 loop this side. So first carbon having 1 electron, second carbon also having 1 electron in that 3. So here I said 1 2 3, fourth electron here s2, no, that 1 electron jumps here. No, this orbital is not participated in hybridization. That orbital belongs to this carbon. I want to write how? Like this, bigger only. two loops are big. Same this structure we will write here. Already one I wrote. That is having 3 electrons. One more carbon. This is one. This is one more. No, that carbon also having. See, one big loop and one this side one small. This side one small. For that carbon also like this. One more orbital is there. No, that orbital we can represent like this. Now see, this orbital having also one electron, no, single electron, which is comes from s orbital, Now here there means enough. Here one, 3 for that, here 1 4, 3 for this one, here for 1. Now see how many bonds. This is will form with hydrogen. This is also will form with hydrogen. This is also hydrogen electron with hydrogen have 1 electron, no, in valency. That electron, this one also 1 hydrogen. Now in this two will form pi bond. What that bond? Pi bond. This one is sigma bond. Now understood the carbon how many bonds is there? C carbon, 2 carbons, carbon double bond is there. One is sigma bond, other one is pi bond. That we can represent 2 dashes. And carbon and hydrogen one single dashes we will represent. See, in this carbon having 2 hydrogens, in this carbon also 2. That is I represent here 1 hydrogen, 2 hydrogen, 1 hydrogen, 2 hydrogens. Okay, this is the about hybridization, how it will form pi bond. Special type, no, pi bond is that. Okay, very good. Next we will discuss about structural representation of organic compound. Structural representation, how it is. I will write some structural structures. 3 types of structures is there here. What is that? First one is complete structure, structural formula. Complete structural formula. Second one is condensed structure or structural formula. This is also condenser structure, also no problem. Structural formula also no problem. Next, bond line structure. Like these 3 types we can represent organic compounds. Very basic chapter. Listen. Complete structure means, example, I am taking some examples for first one. For first one, here first. So what is that? Complete structure means, example, one carbon atom having 3 hydrogens. This carbon attached to one more carbon. It is having 1 oxygen with a double bond. This side also 1 carbon. It is having 2 hydrogens. Like this is there. This structure, how it is there? Completely with dots also. This is a Lewis dot structure. Oxygen having 6 valence electrons we are representing like this. Hydrogen having 1 valence electrons and carbon having 4 valence electrons. That we can represent that the electrons only participated in bonding, involved in bonding. This is the complete structure of formula. This name is ketone. This is a functional group is ketone. 3 carbons is there, means what we will call 1 carbon methane, 2 carbons ethane, 3 carbon propane. This is propanone, 2 propanone, or propanone also enough because this is not a chain terminating group. No, propanone or ketone is general formula, general name. This is ketone. So if one more example same we will take means CH3 CH2 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 CH3 like is there. So this is also complete structure. How many bonds, how many atoms is there, all together is there. So that only these 2 complete structures. Now condensed structure means what, sir? Condensed, second example, see, condensed structure means like CH3, CH2, CH2, CH3. Here no bond representation. There is no representation for this dash like bonds, dash like representation not having, so that only this is condensed. Example, one more example, CH3, CH2, CHO, no representation. So this is aldehyde group. This one we will call 1 2 3 carbons, no, propanol, Al. This is 1 2 3 4 carbons means butane. All are single bonds. Hydrogens is there, no, single bonds. This is condensed structure, sir. This is a complete structural formula. So this is the difference between condensed and complete. Next one, last one, bond line means what? Bond line means like this is there. So every corner one carbon present, or zigzag line. Zigzag line means like this is there, means this corner, here all carbons is there. So represent zigzag line or bonded line. That structure having every corner or end carbon is there. 1 2 3 4 5 6 7 8 9 carbons total is there. This is how it is. If complete structure I want to write means carbon, one more carbon, this is one carbon, this is one carbon. Same here one carbon, here one carbon, here one carbon, here one, like this. Hydrogens, here CH3, here CH2, end CH3 is end carbon have CH3 because carbon valence is tetra. End CH3 and middle CH2 is there. Now this name how we will write? 1 2 3 4 5 carbons like this. Okay, for 3 carbon having 2 side chains, then what we will call 5 carbon means pentane, right? All are single bonds, no, pentane. Third having 3 comma 3 di means 2. 3 comma 3 means third position having ethyl group. One more third also ethyl, C2H5 ethyl only, no, C2H5 ethyl, diethyl pentane. 3 comma 3 diethyl pentane. So this is bond line structure. Okay, understood, Amma? Next 3D representation of organic molecule. OZ means organic, M means molecule. 3D structure for representing carbon and hydrogens. So we have 4 hydrogens in carbon, no, like this we are writing like this, but it is wrong. For writing exam we will write like this, no problem, but representing we want to know, no. So carbon near to observer we will write solid wedge structure, wedge bond, solid wedge. Solid wedge dash. This is a near to observer. This is a plane. Plane means on this plane means on the plane we will represent 2 atoms. That is like this. 2 atoms is there on the plane. This is your side, and one more I am writing. This hydrogen is away from the observer. So that side is a board, that side. This is board, this side. This is the left side, this is the right side. Like is there. So this is the 3D representation of a carbon organic molecule. This line we will call, this is a solid wedge, this is dotted this name dotted wedge like we will call 1 minute, that we will call solid wedge, and away from the observer dashed wedge, dashed wedge. This is on the plane, so this is a 3D representation of organic molecule. Okay, this is about fully introduction of these 4 points. Next class we will discuss remaining concept. Thank you. Please subscribe my channel. Thank you, students.